Hi, Year 10. Today we're going to continue on with quadratic functions. And we're going to pick up where we left off last time, sketching parabolas by finding our axis of symmetry, by finding our vertex, by finding our x-intercepts, by finding our y-intercept, and combining all that information into a graph. And so let me go through this first example with you, just so that we can remember what we did last lesson. So let's begin with finding the axis of symmetry. And to do that, we use the formula x equals to negative b over 2a. In this case, b is negative 6, and a is simply just 1. Okay? And so when we substitute those in, we get negative of negative 6, 2 times 1 on the bottom, so we get 6 over 2, which gives us 3. And that means that that is the x value of our axis of symmetry, but also the x value of our vertex. When we sub this x value into our parabola equation, our quadratic equation, we will get y is equal to 3 squared minus 6 times 3 plus 8, and that will give us negative 1. Now, that is the y value of our vertex. So combining this information together, we now know that our vertex is at 3, negative 1. And we can plot that onto the graph like so. 3, negative 1. We also know that this parabola is opening upwards. And we know that because the number in front of x squared is 1, which is positive. Okay? Now let's find our x-intercepts. To find our x-intercepts, we're going to let y be 0. And when we do that, we can see that we have a quadratic equation that we can factorize. And I'm just going to do the work for you. When we do factorize this, we will get x minus 4 and x minus 2. And this tells us that our x-intercepts are at x equals to 4 and x equals to 2. And so we can mark that on the graph like so. After that, we just have one last piece of the puzzle, which is finding our y-intercept. And that's very simple. It's just letting x be 0. And immediately you can see that when we let x equals to 0 in this quadratic equation here, the first term will disappear, the second term will also disappear, and then we're left with just 8 at the end. So we know that it's going to cross our y-axis at 8. And it seems like it's actually off the axis, so it's going to be somewhere up here. And so if we draw our parabola in now, we can see that it's going to look something like this. Opening upwards, with x-intercepts at 2 and 4, with a vertex at 3, negative 1, and with a y-intercept of 8. So guys, that was what we did last lesson. And so to re-jog your memory, I would like you to now give B a try without my help, so please feel free to pause the video here. Okay, moving on, we're going to look today at some new forms of parabolas. I want you to pay attention to this one, and also this one here. You'll notice that these parabolas have been factorized, or what we call completed the square, right? The square has been completed for us, as you can see. Now, we call this a very particular, we have a name for this. This is called the vertex form, okay, as you can see there, of the quadratic function. Okay? Now, why is this important? This is important because when a quadratic is in vertex form, as the name suggests, it actually tells us exactly what the vertex is. We can just read it off. So let's pay attention to the vertex form here. It says that the vertex form is a x minus h squared plus k. Now let's focus on this h and this k here. What is h and what is k? Well, hk, we're told, is the vertex of the parabola. Okay? And if we look at our first example up here, right, it looks like instead of h, we have 3, and instead of k, we have -1. So in this case, k is -1, and h is 3. And this tells us that our parabola is, our vertex, sorry, is 3, -1. And so let's actually be a bit careful here. Our vertex isn't at -3, -1. So if you see a minus, we don't include the minus there, okay? But if you see a plus, if this was x plus 3, the vertex would be at -3, -1, okay? So it's very important to distinguish between that, okay? And so the reason why this is so useful, actually, is because now we can simply draw the vertex in immediately. And it turns out, actually, I think, that this actually gives us the exact same graph as the example above. So you don't have to take my word for it, actually. I can actually show you that when we expand this parabola here, we will get x squared minus 6x plus 9 minus 1, right? And that gives us x squared minus 6x plus 8, which is exactly the same parabola that we drew in our first example, okay? But it's actually been what we call, we've completed the square, right? And so that's how we go from a normal general form of the parabola to the vertex form of the parabola. Okay? The method from going to from the normal form to the vertex form is completing the square. Okay? And that's very important, okay? Because let's say you're trying to draw a graph, and you forget x equals minus b over 2a. You forget. You're like, oh, I can't remember the axis of symmetry formula. So instead, what you can do is you can rely on this. You can complete the square, because I'm assuming you can. And once you've completed the square, well, what do you do next? What do you do next? You simply just read the vertex off the vertex form. All right, and we'll practice doing that. So let's actually have a look at the graph here. You'll notice here that there's no k value, right? There's no number, like plus k, there's nothing there. What that means is the vertex has actually got a y value of 0. But what is the x value of the vertex? So now we've got to be careful, right? Because we've got x plus 1 in the bracket here, which means actually that the vertex, or in other words, h, is actually equal to -1. And in this case, k is 0. So actually our vertex is actually at -1, 0. Right? And I'm assuming this is also the same graph as part B above, right? And so if you did part B up there, this part B is actually exactly the same graph. And so if you get a different vertex here, then you've done something wrong, okay? And so that is just a brief introduction to the vertex form. Let's actually do sort of an exercise to sort of think about the vertex from the vertex form. Okay, so let's actually practice that using these examples. So let's have a look at the first one. The first one, what is h? And what is k? So in this case, h is not 2, but actually -2. And k is actually -5. Okay, so you'll notice that k, we actually include the sign, But for h, we have to do the opposite sign, okay? And so this tells us that the vertex is simply hk, which is -2, -5. Let's also do the second one here. What is h and what is k? In this case, h is 1, because it's the opposite sign, and k is +3. And so our vertex is at 1, 3. Now let's look over here. Now, if you look over here, you're like, whoa, wait a minute. There's no bracket, right? It's just x squared. Well, it turns out that h here is actually just 0. And k is the number out the back, which is 4. And therefore, our vertex is actually at 0, 4. Right? Are we starting to get the idea? Right? This is really important. This is mind-breaking, right? Because once we have a parabola's equation in vertex form, our life becomes very easy, right? We can read the vertex like this, rather than x equals minus b over 2a, sub it in. Like, who wants to do that, right? If we complete the square, we can just read the vertex like that. And so that's a very important skill, okay? So we need to practice doing that. And so hopefully you can actually match these parabolas to the pictures down here. I'm not going to help you too much. Just pick the one that has the right vertex and is opening in the right direction. And so I'll let you have a go at that. So you can pause this video now and try to match each equation to one of the graphs below. There are 6, but obviously I've just thrown 3 other ones in there to mess with you. So make sure you match the correct ones. And yeah. Okay. So for example 3, I want to start helping you think about how the equation of a parabola changes the shape of the parabola. Okay, so let me actually show you what each of these parabolas look like, just with a rough sketch. Okay, y equals to x squared. That looks like this. Okay, this is y equals to x squared. Notice that the vertex is at the origin, all right, at 0, 0. Okay, now that's the original parabola. Okay, now what's going to happen is if I put a +3 inside the bracket, what this actually does is it shifts the parabola not to the positive side, because you'd think, oh, +3, that's moving towards the positive side, right? No, it's actually shifting to the negative side, to the left. Shifts left. By how many units? Well, 3 units. And so what the parabola actually looks like is it looks like something like this. Okay? It's shifted left 3 units. So it's as if I picked up the normal parabola and shifted it left 3 units. That's what I've done. Now, what about the one over here? Well, let's take it apart bit by bit. Let's just focus on the bracket, right? If the previous one was shifting to the left because it was plus, well, now it's -4. -4, the opposite of minus is plus. So we're actually shifting to the positive side. We're shifting to the right by 4 units. Right? And if you don't believe me, actually, you can actually find the vertex. The vertex will be at 4, not -4. So it's been shifted to the right, right? And what this -1 does at the back is that's the number that controls up and down, right? So in this case, -1 means we've shifted the parabola down 1 unit, right? If it was +1, it would have shifted the parabola up 1 unit. And so this tells us that we're shifting the parabola down 2 units. Oh, sorry, not 2 units, 1 unit. And so therefore, if we're taking the parabola, we're shifting it right 4 and then down 1, the vertex is at 4, -1. And so that's what the parabola looks like. Okay, so 4 and -1. And so thank you, Year 10. Hopefully that's been helpful. And I would like you to feel free to rewind this video, and I would like you to attempt the first worksheet, okay? If you do have any troubles, feel free to message me. All right, thank you, Year 10.